So, hello everyone. Now I am here to explain PowerPoint presentation of project washing machine for completion of my embedded system internship from the Emerxe Information Technologies. Let me introduce myself. My name is Fazal and I am from RGKT Ongol. Here our project name is washing machine. It is an application of an embedded systems. So the things we have learned from the internship are introduction to C, conditional loops and operators, arrays and pointers, functions and strings, storage classes and embedded system and microcontroller, washing machine project, MPLab, XE8 and PiximLab. These are the tools of the embedded system. Introduction to various peripherals of PIC16F877A microcontroller. Interfacing various peripherals of PIC16F877A and various quizzes. In these internships, these are the topics I have learnt. Next, table of contents. Introduction to embedded systems and the components of an embedded system, embedded programming, about the project and the project implementation demo video is also included in this video. Introduction to embedded system. An embedded system is a small computer designed to perform a specific task within a larger device. It consists of a microcontroller or microprocessor, software and hardware components working together to control functions like sensing, processing and output, etc. Examples include washing machine, traffic lights and smartphones. So here these are the picture of some examples of the microcontroller. There are industrial robots, GPS receivers, digital cameras, DVD players and microwave oven, photocopiers, gaming consoles and etc. These are the applications of an embedded systems. An embedded system is a combination of both hardware, software and also firmware. Components of an embedded system. The following picture is shown below of components of embedded systems. In this picture there are input ports and output ports and the other devices and memory. Input devices. Input devices means we are giving some inputs to the microcontroller or microprocessor. Output. Input ports are nothing but sensors. Output ports. Output ports are giving output of the microcontroller and outputs are also known as actuators. Memory. Memory is a device to store the code or the program of the project. Other devices. Other devices are also known as peripherals like CLCD for displaying the screen and digital keypad and fan and buzzer, etc. System core. System core is nothing but microprocessor or microcontroller. So this is a picture of an components of embedded system shown here. System core. System core of an embedded system includes microprocessor, microcontroller, FPGA, etc. FPGA means field programmable gate array, etc. 8085 and 8086 are the few examples of microprocessors. ARM Advanced RISC Machine DSP Digital Signal Processor 8051. PIC Peripheral Interfacing Controller are the few examples of microcontroller. In this washing machine project we are using PIC16F877A microcontroller. So what is microcontroller? Microcontroller is an integrated circuit which is capable of being programmed to perform a specific task. A microcontroller is a device used to perform a specific task. The design normally has restrictions on its memory size and input output capabilities and peripheral functions, etc. Microcontroller. This is the picture of a microcontroller PIC16F877A. Microcontroller, in this all the peripherals are separate components and it is more flexible and it is more designed to complexity. So in this all peripherals are separate components. Microprocessor. This is the picture of a 8085 microprocessor. In microprocessor, all the components are in a single chip. It is less flexible and lesser design complexity. Embedded programming. Embedded programming refers to writing software that runs on embedded systems, which are specialized computing devices designed to perform specific tasks. It involves low-level programming to control hardware components like microcontrollers, sensors, and actuators. So, most popular languages for embedded system are C, C++, Python, Java, Rust, and etc. Mostly we are using C for embedded systems. Here are some differences between C and embedded C. C is a general purpose language used for developing software, while embedded C is specifically designed for controlling hardware in embedded systems. C. C runs on the computers with operating systems like Windows, Linux, or Mac. C program have more memory and processing power available. Embedded C. Embedded C runs directly on hardware microcontroller without an operating system. Means it does not include operating systems like Windows, Linux, or Macs, etc. Embedded C must be optimized for small memory and low usage as embedded devices have limited resources. Introduction to Embedded C. Embedded C is a programming language specifically used to develop software for embedded systems, which are small computing devices designed to perform dedicated functions. It is an extension of the C programming language, but with additional features that allow direct interaction with hardware components like microcontrollers, sensors, and actuators. Embedded C is very similar to the C language, and some of the differences may occur. Key features of an embedded system. First one, uses a standard C syntax. Similarly into C, including loops, functions, and conditions. Second one, direct hardware access. Uses registers and ports to control hardware components. No standard library functions. Unlike regular C, functions like printf and scanf are not commonly used. Efficient memory management. Optimized for minimal RAM and ROM usage. Real-time processing. It ensures immediate execution of tasks critical for embedded applications. Data types and variables. Embedded C uses standard C data types, but they are optimized for embedded systems with limited memory and processing power. It also includes hardware-specific data types that interact daily with microcontroller registers and memory locations. Data types. There are two types of data types, basic data types and derived data types. Variables. There are two types of variables, local variable and global variables. Basic data types are integer, character, float and double, etc. These are the examples of the basic data types. Derived data types, arrays, pointers, structures, unions, etc. These are the examples of the derived data types. About the project. In the project, we are simulating washing machine, which is known as a popular application of an embedded system using PixSimLab. So what is a washing machine? A washing machine is a machine designed to clean clothes and other fabrics, typically using water and detergent. It automates the process of washing, rinsing, and sometimes drying clothes, saving time and effort compared to hand washing. Architecture of a PIC-SIM lab. So this is the architecture diagram of a PIC-SIM lab, PIC16 of 8 a microcontroller. So there are various peripherals like matrix keypad. It is used to give input and takes output, and digital keypad is used to give the input, and buzzer is also used to take the input, and LEDs are used to show the output, and the temperature LM35 sensor is also used to give the input. So this is the total architecture of the PIC16F800 microcontroller. So this is a picture of a microcontroller PIC16F877A. So what for the washing machine project simulation we are using PIC microcontroller. We have various versions of PIC microcontroller. Among all of them we use PIC16F877A. It is a 8-bit general purpose microcontroller. RISC, flash memory are key features of this PIC microcontroller. It is a 8-bit microcontroller. And in this we are also learned various peripherals, like some of them are CLCD. CLCD full form is a character LCD, liquefied crystal display. Is a simple display screen used in embedded system to show text, numbers and symbols. How does it works? It receives the data from microcontroller, process the data, displays the data. So this is the picture of the LCD. It is of two types, 16 cross 2 and 16 cross 4. In 16 cross 2 there are two lines. In each line we are displaying 16 characters. In the 16 cross 4 there are 4 lines. In each line we are displaying 16 characters. So this is the picture of the LCD, liquefied crystal display. Another one peripheral is digital keypad. Matrix, it is also known as matrix keyboard. A matrix keyboard or matrix keypad is a type of keypad with multiple buttons arranged in rows and columns to reduce the number of required input pins. It is commonly used in embedded systems, calculators, ATMs, security system and industrial etc. It is also used in password door lock systems to enter the password for the opening of the doors and etc. So another peripherals also there like fan, buzzer are used in this project. Fan is nothing but uh, for the running of washing machine we are using a fan, and to detect the output we are using the buzzer. So this is about the presentation, and now I am here to discuss about the project demo video. So now I am opening MPLAB XIDE of the washing machine project. So and here there are some header files and some source files. In this main.c, this is main.c function. Mm, this is main.h function. In this macros are defined. This is a fan macro and buzzer macro. To define on and off we are using some macros. Instead of doing all in one main.c, we are using different .c files, source files. Here clc.c used to display the letters on the LCD, and digital keypad.c, this is also included in this file, and it is irsr.c, use it for the timer, and washing machine different.c also included in this file. These are the header files, clc.h, keypad.h, timers.h, and washing machine header.h. So now I am going to um, Now I'm here to about the show the output of my project. So I'm opening Pixim Lab. In this we have to select microcontroller PIC16F877A and board we have to select PIC Genius. Clock frequency would be 20 megahertz. So here we are displaying for loading of the hex file. I am loading the hex file. Here I am saved in the documents, embedded folder and washing machine project, distributor, default, production, hex file. I am opening the hex file. So the hex file is loaded in this Pixim lab. So first screen is press key 5 to power on washing machine. So when we press the switch 5, it's power on the washing machine. Now I am pressing the switch 5. So these are the switches: switch 1, switch 2, switch 3, switch 4, switch 5, switch 6, switch 7. Now I am pressing switch 5. So washing machine is powering on. So it displaying powering on washing machine. Now another screen is washing program screen. In this there are various types of cloths types. The first one is daily, heavy, delicates, and to scroll down the cloths we are using switch 4. So this is scrolling down: dedicates, white, stain wash, eco cottons, woolens, bed sheets, rinse plus dry. So these are the types of cloths we have in the washing machine program screen. So if we long press the switch 4, then it is turned to another screen, that is water level screen. Now I am pressing switch 4 long press. So the now screen is changed to water level screen. These are types of water levels: auto, low, medium, high. Now to change from the another screen, I am long pressing the switch 4. Now we have displaying press switch 5 to start and switch stick to stop. So if we press switch 5, then the washing machine starts running, and if we press switch stick, it stops the running. So I am pressing switch 5. So it is running on the washing machine. It is displaying function. It is either it is wash or rinse or spin. The time is displaying, and if we press switch 5, it starts, and if we press switch 6, it stop pause. Now I am pressing switch 6 for pausing of the washing machine. So now it is paused, fan is off, and buzzer is also off. When I press switch 5, it again ons. So see, the fan is running. So if we open the door, then it is sensing door is open, please close the door. When I am pressing switch 1, the door is open, long pressing. Like, please close the door, it is displaying. So the program changes to rinse. We have set some time in the program to change from to wash to rinse and spin. So now if I press switch 6, it pauses, fan will be off. Now again if I press switch 5, it starts running. So program is completed, the buzzer will be on, and if we displaying program is completed, remove clocks. So it is my project, the output is shown. And so thank you for Emerxe Information Technologies for providing this internship opportunity and helping us to gain some practical knowledge on embedded systems, and doing some washing machine project is worthy. So thank you Emerxe. I'm very happy for this project.